So I will quickly share the presentation. There's Inga from the Joint Secretariat, Project Officer. We have Nicole, who's the contact point from Luxembourg, and myself, Matthew Thompson. I'm the Project Officer at the Joint Secretariat. So today's agenda, we will cover resource recovery, how it's addressed in the current program. We'll look at two presentations on Interreg Northwest Europe, SEDASI, Circular Economy for the Data Center Industry, presented by Dr. Deborah Andrews, and Redirect, Regional Development and Integration of Unused Biomass, Waste and Resources for Circular Products, and the Economic Transformation, presented by Dr. Tim Schultz. We'll then look at how resource recovery will be addressed in the new program, and then we'll have the roundtable breakout sessions. So for the technical aspects, you can ask questions via chat, and if you can keep your mic muted and camera off during the presentations, please. So just to quickly discuss about resource recovery, one of the easiest ways to do it is to look at linear versus circular production. This is useful in the context of the program. There's been an overall shift towards a more circular modes of production, in which outputs can become new inputs either for the same processes or for new products and processes. As you can see from the diagram, normally resources are extracted, things are made, they're distributed and stored. They're sent to people which use them at home and at work, and then we dispose of them when they're no longer used, when they no longer function or no longer useful, and then they're dumped. And this is true of everything from a litre of milk to an aeroplane or a skyscraper. Interventions in creating circular production can happen at a whole range of different stages. Sometimes they're within the same sector, sometimes it's downscaling or upscaling. The types of interventions are incredibly diverse. We have recycling, remanufacturing, refurbishment, service and repair. What we have seen in Northwest Europe is that our projects, they focus on part of this circle and not the entire chain. This makes sense from a practical point of view, given how complex the supply chains are, there's limited project budgets and the limited time frame. However, these project interventions are vital in helping to create a truly circular economy. All of this is taking place in a wider policy framework. So, for example, we have the released in 2010, the Europe 2020 strategy for sustainable growth. This focuses on smart growth for the development of economy based on knowledge and innovation. Sustainable growth by promoting resource efficient use and greener and more competitive economy. And increasing growth through fostering high unemployment economy, delivering social and territorial cohesion. This particular sort of policy helps to influence EU programs such as Interreg. We now have the new EU Circular Action Plan, which includes measures for making sustainable products the norm in the EU, placing a focus on the sectors that use the most resources and where the potential for circularity is highest, such as electronics, batteries and vehicles, packaging and plastics, textiles, construction and building, food, water and nutrients. We also have sort of more global approaches. So the UN Sustainable Development Goals 12, which asks countries to implement a 10-year framework on programs of sustainable consumption and production, where the developed countries, like those in Northwest Europe, are meant to take a lead. And at a sort of our program level, there's the current Interreg Northwest Europe specific Objective 5, which is many of the projects you'll see later fall under. And this focuses on the optimization, use and reuse of materials and natural resources in Northwest Europe. Overall, the projects in Northwest Europe, we have identified sort of 14 projects, and they cover everything from resource recovery, waste extraction from biomass, landfill, recycling, repair, and repair of digital infrastructure. I should point out that we also have green construction projects, which would very much fall under this field, but we have a separate breakout session for those. Of these projects, there's over 160 partner organizations involving thousands of people. And overall, we've had a budget of 74 million ERDF. These are the projects that we have. So we have things like Transform CE, where they're transforming single-use plastics into feedstock. Rawfill, which is looking to extract raw materials that have already ended up being dumped in landfills. Phos4U, for example, is looking at the upscaling of the extraction of phosphorus from wastewater, which is vital for modern agriculture. And SharePair, which aims to decrease consumer electronic waste by upscaling citizens' repair initiatives using digital tools. We'll now have two presentations. So first will be SIDASI should be Dr. Deborah Andrews, and then it will be SharePair. So I will stop sharing my screen. Okay.
Thank you, Matt. So now we will leave the floor to Professor Deborah Andrews, who will make a presentation about the SIDASI project on behalf of the lead partner, which is the London South Bank University. So please, Deborah, the floor is yours.
Okay, thank you very much for the introduction. I hope everybody can hear me, and I'm going to share the screen. Okay, so good morning. Yeah, I'm Deborah Andrews. I'm the lead academic on SIDASI, a circular economy for the data industry project. So data centers are basically spaces that house digital processing and storage equipment. The sector has grown astronomically quickly. There are around 7.7 million around the world now, and there's a concentration in the EU because of the financial sector, so concentration in UK, Germany, France, and the Netherlands, and it's worth a vast amount of money. $100 billion has been invested recently in the sector. So now we process about 4.2 trillion gigabytes of data per year, and 60% of the global population are connected. So that gives you an idea of the scale of the sector. It's going to continue to grow, about 300% in the EU by 2025 and 500% around the world by 2030 because of the introduction of phenomena like the Internet of Things. So the sector has grown up in a very linear way, where, and this is partly to do with the speed of development and also the manufacturing processes and so forth of the products. But basically we take, make, use and dispose of products. And because of factors like planned obsolescence and short lifetimes and so forth, there is a really rapidly growing pile of e-waste. At the moment, there's about 50 million tons a year, which equates to 6 kilograms per person is generated. And if we carry on doing what we're doing, this will escalate to 120 million tons a year by 2050. At the moment, only 20% of e-waste is formally collected and recycled, but we're not really sure exactly how much is recycled because the informal sector is very difficult to measure. But you can see in EEE, electrical and electronic equipment, there are about 69 elements, 7 to 10 of which are critical raw materials. In other words, they are a very high economic value and very, very important technically, particularly to electrical and electronic equipment. And at the moment, a lot of those are being lost in landfill or so forth. So the objective of the SIDASI project was to move from this linear economy to a circular economy. Now, in this case, it's not just about recycling, it's about reducing or dematerializing the amount of materials embodied in products themselves, in promoting reuse through refurbishment and repairable products, and ultimately in recycling, certainly increasing recycling capability, and also in developing new materials reclamation process, critical raw materials reclamation processes. This is really so that we can develop a secure and robust supply chain for these materials. There's a lot of land grabbing or resource and mine purchase in Africa by other countries so that they can control resources. So if we can develop a circular economy, this will contribute to keeping the data center industry supply chain nice and robust and secure. And we can continue to have uninterrupted supply of digital services, because obviously we're now so dependent on them. So SIDASI, the predominant objective was to adopt a whole life thinking approach and bringing together representatives from all the different subsectors across the industry, because at the moment there's a trend of silo working. And we really need a holistic approach to develop a circular economy, a holistic approach where actors from all the various subsectors can collaborate and understand the implications and activities within each subsector in depth. And ultimately, we will reduce waste, prevent supply chain problems to secure uninterrupted data center operation and service in the future. So the project, since we've been running, we started in October 2018 and really kicked off in earnest in January 2019. We operate through co-creation workshops, working groups. We've developed a professional network of 100% members, mainly from industry. And the project was the runner-up in the Data Center Dynamics nonprofit initiative, their global awards in 2019. So we're very proud of that. We're also very proud of the fact that the project was highlighted as an exemplar of good practice by the EU CE stakeholder platform. So you'll find us on there too. So to date, our achievements and outputs. So we have 3 integrated pilots that focus on different life cycle stages. The first is design and manufacture, the second life extension through secondary markets and refurbishment and so forth for those. And then the third is end of life, when we're focusing on recycling and reclamation of critical raw materials. And as I mentioned before, in particular, materials that aren't collected by other recycling processes. So these pilots are integrated so that we can collect data to contribute to an extensive database, which has allowed us to build the Circular Data Center Compass. And this is a free online tool for anyone who's interested in looking at the advantages of refurbishment, recycling, etc., and looking at the whole life cycle impact of different data center products. At the moment, we're focusing on servers, but also we're developing new business models to promote the economic benefits of practices in the SIDASI project. We're also presenting eco-design guidelines for the circular economy. These are based on the action plan and various EU regulations and so forth. And all of this information, as I said, it feeds into the Circular Data Center Compass, but we're also offering one-to-one technical assistance for SMEs to help them to understand the importance, relevance of the circular economy and how to use the tool. And we are providing information to policy guidance, policymakers and influencers. We have physical and virtual demonstrator products, and ultimately we will kickstart the circular economy for the sector. So to date, we have, by the end of the project, we had a 6-month extension because of COVID. So the initial project will end in 2022, in April 2022. And within the project, we'll have recycled 80 pieces of equipment and reclaim 3.8 kilos of critical raw materials. Now that may not sound very much, but by mass, only 0.2% or 0.02% of the mass of a server, for example, is comprised of critical raw materials. So their value far exceeds their physical mass. Because of the program and the strategies we're developing, after 10 years, we expect to have reclaimed 309 tons of critical raw materials and to have offered 50 SMEs training, and that's at the end of the initial project. So we were really, really pleased that we won an extension. We have successfully now able to take on the capitalisation initiative to extend geographical scope and also technical scope of what we're doing. And this will allow us to increase critical raw materials reclamation, recycling by 25% during the project. After 10 years, it represents a 10% increase. And also we are able now to reach around 100 small to medium enterprises and offer training, support and advice and so forth. So we're really, really pleased about that. So notable things in the project. Well, one remarkable thing, and it is coincidental rather than planned, but we're really proud that many of our team members are women, which is very unusual in such a male-dominated sector. We have a wonderful time working together. The team is absolutely fantastic. We've had meetings in London, in France, in the Netherlands, etc. And as we've developed friendships as well as professional collaboration, which is great. So we're a happy bunch. And we also have enjoyed many of the local beverages in the various places where we've had our team meetings. So we're very sad that most meetings have been via Zoom or whatever recently, and we're hoping to be able to meet again in person in the near future. So thank you very much for listening. If you have any further questions, then please don't hesitate to ask. But you can also find our website. We have a dedicated project website and also an Interreg website. So we regularly publish information about our progress and so forth. So please do look at that. And I can't recommend Interreg highly enough. It's been a brilliant experience for us. Thank you very much.
Thank you, Deborah, for your kind words and for your interesting presentation. So now I would give directly the floor to Tim Scholz to make a presentation on the project Redirect, which addresses a completely different kind of waste. It is focused on biomass. So please, Tim, the floor is yours.
Yes, hello. Thank you very much for the occasion to present the project Redirect. And let me just share the screen for the first time. So as Matt already mentioned, the title of our project Redirect stands for Regional Development and Integration of Unused Biomass Wastes as Resources for Circular Products and Economic Transformation. In short, it means simply that we try to use waste biomass wherever it appears and turn this waste into something useful, so to achieve a reduction of waste and at the same time a kind of a utilization for different purposes. I would like to stop first of all this presentation and well, show you a little video. So this is going to be an experiment and I hope that it works. A video that we produced, probably it was in 2017 and 2018, and it reflects a little bit the starting point of the Redirect project. And don't take it too serious, it's a little bit comic style. However, I think it was quite successful because we could reach a number of stakeholders, especially on the regional level, to interest them for this topic of well, the reutilization of bio-wastes. Just give me a second to share my screen, and I hope that this will work as well. So this is a YouTube video, and I hope that you can hear it.
Imagine you were in the land of utopia. There are no energy problems here, because the energy grows on trees. The bushes heat your living room, and hot water can be found by the wayside. Coal is growing everywhere, and it's very active. And now imagine you could use all this energy, CO2 neutral and climate friendly. Wouldn't that be wonderful? But maybe utopia is closer than you think. Let's take bushes and trees, for example. These are cut back regularly. These cuttings come to the biomass yard. Here they are processed into wood chips as fuel for the wood stove or the biomass boiler. Or the leaves that fall from the trees in autumn and the mown grass from the meadows. These are processed into silage on the biomass farm. This is later used to produce biogas, which is converted into electricity and heat in the block-type thermal power station. The solid components of the silage are processed into fuel. But that's not all. Now imagine that you could also produce coal from all this biomass. Abracadabra, pyrolysis. Pyrolysis transforms the carbon from the biomass into coal. Many good things can be done with this plant-based charcoal. For instance, for improving the quality of soils, or using it as fuel and to grill ecologically. The redirect barbecue charcoal does not cost trees and is even cleaner than conventional barbecue charcoal. But also valuable activated carbon can be produced from biomass. It is suitable as an ecological raw material for cosmetics and cleaning agents, and also for pharmaceuticals. Above all, however, it can be used in sewage water treatment plants to free groundwater from drugs and antibiotics. If we use biomass properly, we can make utopia our country. Welcome to Utopia.
Well, this is a little introduction into the scope of things that we have been doing, and let's come back to the more technical, excuse me. Sorry, I don't know if you see my screen. Okay, so now it was going on. Okay, so how did we start? Actually, our challenge in technical term is as follows. So at the moment we have 35 million tons of biomass that are wasted per year in Northwest Europe alone. And at the same time, we have 70,000 tons activated coal, which is imported into Europe, and which is, of course, produced under, let's say, not sustainable conditions. Not sustainable means under not sustainable ecological and, of course, also social conditions. So this is something. This is our starting point, in a way, and the question of how can we change that. And well, our initiative has not started with the redirect project, but we have a little bit of a longer history. Our main center is in Kassel, in the middle of Germany, at the University of Kassel, which is, by the way, the only university in Germany for organic agriculture. And there we already started in 2007 and 8 with a project which was funded by the Life Environment program, which was called Progress. And Progress was aiming at upscaling a method which was developed in Kassel in 2000 to separate press fluid and press cake when turning grass into a material that can be burnt, because normally this is not so simple. You have a lot of harmful substances, so that you have to take care of. You cannot simply burn straw or grass or something like that and use it for energetic purposes. Therefore, one professor came across the idea to separate that, and developed a system which he called IFBB, which is basically this separation of press fluid and press cake. So that is the thing that you also saw in this little video already. This is the meshing and the pressing, and then the harmful substances, to put it in a layman way, go into the press fluid, go into the biogas, and then we can further work with the press cake. And this was really a kind of starting point. And then Interreg helped us very much with the first project called Combine, where we used this material well, developed a large-scale plant in the city of Baden-Baden to experiment on the IFBB procedure and use roadside materials, because if you just go travel through European countryside, you see a lot of waste material that, of course, can be used, and which rottens somewhere or is simply waste. And we used this in Combine for thermal conversion, but then we were facing a lot of problems, especially from the legal point of view, because if it is treated as a waste, you cannot simply, the economic utilization is simply not as possible as if this would be a valuable agricultural substance. So we had to look for new ways to use this, and we came across this pyrolysis idea to change from thermal conversion to conversion into products. And well, this is the next process step in Redirect, and we are extremely grateful that we got this opportunity to roll that out in the Redirect project. And to turn this press cake into biochar. And this was both piloted in a large-scale urban and a small-scale farm level in Baden-Baden and in Wales. And we explored regional potentials for different kinds of waste raw materials in Germany, Belgium, UK, Ireland, and in France. So this is how it looks like. In a way, we have developed or researched and piloted different process modes and plants, large scale, small scale, or also mobile, with this separation of fluid and solid press cake, so IFBB and non-IFBB, and also we worked on charcoal and activated charcoal. So there was an optimization of the pyrolysis step. The interesting part here is that it is still very volatile, because research on charcoal, on biochar and activated charcoal is a rather young discipline. So in fact, if I come back to the objective of Redirect, it aimed at increase the use of residual low value and waste biomass, and to convert it into products, into carbon products, and to create biomass to product value chains. And what is extremely important for us is that we are all the time working on this regional or local level. So it doesn't make much sense to transport these things through Europe, but they should be mainly produced and also converted and then reused as products in the locality. So we wanted to set up 2 conversion plants on different scales. Different feasibility and sustainability studies should be carried out, and the objective was to recover 20,000 tons of waste biomass. And the project is over and we could reach these objectives. There were 2 large-scale investments that worked successfully, and their feasibility could be shown in the plans and also on lab scale. The lab scale is still a very important part here because, as I mentioned before, research on charcoal, on biochar is still very much in development. And to give you an example, especially this urban waste in the waste bin that you may have in collection systems, that was thoroughly researched, and it was very interesting because the activated charcoal coming from this area is quite useful to be used in sewage water plants in the 4th cleaning stage in Germany. So that's really interesting because you have, of course, depending on the raw material which moves into this conversion process, a lot of diversity also in the output materials. So it's quite interesting from the research point as well, and from the conversion point, and then later on, of course, also in the product development. So we have proven sustainability of life cycle assessment, and also we carried out economic simulations that are still going on. And as I mentioned before, it is very important to transfer that on the local level as well. We could decrease 24,000 tons of bio-waste, green cut, and nature conservation materials, and produce 1,500 tons of press cake and 50 tons of activated charcoal. Within the project, 25 jobs could be created. And well, we go on because from these projects, we could develop a new one, which is called 3C, standing for Creating the Circular Carbon Economy. And 3C is pushing the whole thing one step further. So from just producing materials, from just processing carbon materials, we are now entering a stage in which we apply a combination of product development, service development, and regional development in this 3C project. The idea is that local biomasses are going to be, let's say, analyzed. There will be surveys. There is also a procedure for following localities to, well, step in the approach as well. And that is a procedure that works quite successfully as well, because many Northwest Europe cities and regions are very interested to, of course, now with the Green Deal and all the frame conditions to somehow turn into greener cities as well and greener regions. So the first step is, of course, to scan well, the environment according to available biomasses, and from there on to develop tailor-made conversion streams, and as last step to create products. And there are various kinds of products that can be produced from this biochar. In the end, this is of course triggered by services, also a possibility, of course, of regional development and to bring new income sources into these regions. And this is my last slide. So this is what we are going to do, or what we have been doing now since 1 year in the 3C project. The idea is to create and to sustain the charcoal value chains and to promote a circular carbon economy in Northwest Europe. And for this purpose, we have installed 3 elements: CC Hubs, CC Labs, and CC Net. CC Hubs are incubators that are well, focusing on the production of carbon products. The CC labs are providing quality assurance and research on these charcoal products for different purposes. And the CCNet in the end aims to mainstream and of course to internationally valorize these products and of course also the network. So that's what we have been doing, and I would like to thank you very much for your attention.
Yes, thank you, Tim. Thank you very much. Unfortunately, we have been running out of time now. We had one question related to the slides. So the answer is yes, slides will be shared. All participants will have the possibility to download the slides afterwards in the coming days. They will receive a link for that. Nicole, I will leave the floor quickly to you to give an introduction as long as possible about the new program. So please take the floor.
Yeah, thanks a lot, Inge. I have the pleasure now to give you some insight how the theme of resource recovery will be tackled in the new program. So here we are. It's again priority 3. It's the transition towards a place-based circular economy, with a focus on promoting the circular and resource-efficient economy. You can see here 3 categories of project activities that we are interested in. The first one is about the elaboration and implementation of joint strategies or action plans, with a focus on place-based strategies. So, for example, for rural areas, for urban areas, regarding eco-design, waste prevention, circular and reverse logistics, but also, of course, waste as a resource approaches, like reuse and recycling. We are interested in pilot actions for testing tools and solutions to be taken up or upscaled. So circularity concepts, including, of course, business models, financing schemes, incentives, maybe on community or regional level. We welcome demonstrations and testing of solutions in a real environment, with the emphasis on real environment. So very applied application of innovation is definitely in the focus of the new program. And of course, capacity building and awareness raising activities in the field of circular economy will also play a role. You have to address at least one of these categories, but you can have more. The target audience is, of course, very broad. It concerns individuals as well as organizations that are involved or positively affected by circular loops. The same goes for beneficiaries or potential project partners, which come from different angles. So we have the public authorities, we have governmental agencies, public equivalent organizations, but also the research partners and, of course, enterprises. Regarding the added value of cooperation, we received a lot of input from our stakeholder analysis. So we have the core of Interreg, of course, the mutual exchange and learning from each other, the collaboration networks that are being built. We offer opportunities for value chain creation and the local replications of good practices that have been tested already in other areas. The tackling of regulatory discrepancies between countries often plays an important role, where the transnational setting is very important. And also the critical mass is sometimes not possible to reach on a national level. So here Interreg Northwest Europe can play an important role. Regarding the expected results, we are looking for the fact that key principles of circular economy are better embedded into territorial strategies, community-led initiatives, manufacturing processes, or business models. We would like to see citizens more engaged in supporting the transition to a circular economy. We want to enable stakeholders to be more capable to adopt innovative solutions for supporting the transition. Of course, the place-based approach applies also tailored solution to local and regional needs. And we are interested in the uptake of innovative technologies and solutions which are by different sectors. And last but not least, the eco-design approaches should be better supported and promoted